All right, let's jump right in. Today, we're tackling a really fascinating puzzle. So you've got this simple, flat 2D image, a chest X-ray of a newborn. And from that, you have to figure out what's going on with their incredibly complex 3D heart. How on earth do you do that? It sounds kind of impossible, right? But believe it or not, this is a puzzle that radiologists piece together every single day.
And hey, don't just take my word for how wild this is. One of our experts actually said that trying to figure this out from an X-ray, well, it's kind of like looking at the liver of a goat to predict the future. And they said this is perhaps even more ridiculous. I mean, that just perfectly sets the tone, doesn't it? We're about to dive into some serious, high-stakes detective work.
So let's really think about this like a detective story. The chest X-ray? That's our crime scene. It's just one single snapshot. And our detective, the radiologist, has to hunt for every tiny clue, every little pattern, to figure out what's going on and crack the case.
You know, to you and me, it just looks like a bunch of shadows. But hidden inside that image are all the secrets to this baby's circulation. And it's not just guesswork, not at all. There's a really systematic way they go about it, a process of deduction that all kicks off with one single, crucial question. And here's the thing, this first massive clue, it's not even on the X-ray. It's a piece of information that someone has to tell the radiologist. And it is the first huge fork in the road for our investigation. Honestly, it changes the entire game.
And that question is the baby blue? That's it. Medically, they call it being cyanotic, and our experts are super clear on this. The clinical team has to give the radiologist this information. Why? Well, because that one little detail takes the huge list of possible problems, our suspects if you will, and chops it right in half. Just like that.
So, what are we talking about here? A blue or cyanotic baby means that oxygen-rich blood isn't getting out to the rest of the body properly. Think of it like a major plumbing problem. Now, a pink or non-cyanotic baby could still have a heart issue for sure, but the main problem isn't that lack of oxygen getting around. And that right there, that is the fundamental divide.
Okay, so based on that one answer, blue or not blue, our detective now has two lineups of the usual suspects. If the baby is blue, you're looking at the cyanotic conditions, often called the 5 Ts. Think things like tetralogy of Fallot or transposition of the great arteries. If the baby's pink, you're on the non-cyanotic side, and you're thinking more about things like holes or blockages. This is the master list, all built from that one critical clue.
All right, let's start our investigation on the non-cyanotic side, the pink baby side. These are often a little easier to wrap your head around because a lot of them come down to something pretty simple: literal holes in the heart.
First up on our list of suspects is the ventricular septal defect, or VSD for short. This is, hands down, the most common congenital heart defect out there. It's a hole in the wall that separates the two big pumping chambers of the heart, the ventricles. And within that, the most common type you'll see is a membranous VSD. That's about 70% of them.
But get this, and this is pretty amazing. Around 70% of the small VSDs just close up on their own. No surgery, no intervention needed. It's just a wild reminder that the body sometimes has this incredible ability to fix itself.
Okay, the next common hole we're looking at is an atrial septal defect, an ASD. This time, the hole is in the wall between the two upper chambers, the atria. But here's the catch, not all ASDs are the same, and for our detective, the exact location of that hole is another huge clue.
And this is where the real detective work kicks in. Check this out. If you've got a secundum ASD right in the middle, that's the most common type. But if our detective sees a primum ASD, one that's lower down, their brain immediately thinks, could this be associated with Down syndrome? And if they see a sinus venosus type way up high, they start looking for another specific issue where the lungs' veins are plumbed in wrong. See? The location tells a story. Okay, let's get to the really cool part. The part radiologists call the smoking guns. We're talking about visual clues on the X-ray that are so classic, so unmistakable, that they are a dead giveaway. You see one of these and boom, you've solved the case.
And they have this great, kind of funny name for it, an ant mini. The logic is simple. The pattern is so distinctive, it's like spotting your own ant mini in a huge crowd. You wouldn't need to do any tests, you wouldn't need to second-guess yourself, you just know. If you see it, you know it.
So our first ant mini case file. This is probably one of the most famous patterns in all of pediatric radiology. The second a radiologist sees this shape, alarm bells just start ringing. This is the case of the egg on a string. And that egg on a string shape, it points straight to a diagnosis called detransposition of the great arteries. Basically, the body's main plumbing is totally backwards. The two major highways leaving the heart are swapped. The egg is the heart itself, and the string is the narrow bit of tissue above it. This is a massive medical emergency, and it's the #1 cause for a baby to be blue in their first 24 hours.
All right, let's open up our next case file. Another unmistakable picture, but this one looks completely different. We're not talking about an egg this time. We're talking about something you might build in your yard after a big snowstorm. This is the case of the Snowman.
So what does the Snowman tell us? It points to a cyanotic condition with a really long name, total anomalous pulmonary venous return. Let's just call it TAPVR. All it means is that the oxygen-rich blood coming from the lungs, it's not going back to the right place in the heart. Instead, all those veins are draining somewhere else entirely. This crazy rerouting of blood flow is what creates that head and body shape on the X-ray. And for these babies to even survive, there has to be another hole somewhere, like an ASD, just to let some of that good oxygenated blood mix in and get out to the body.
Okay, so here's the big takeaway. These shapes and shadows on the X-ray, they don't just exist on their own. They aren't isolated clues. Think of them as the first big signpost, the first major hint that points our detective towards a much bigger, system-wide diagnosis. This is where all the pieces of the puzzle start to click into place. So, for example, if the radiologist sees a specific kind of defect called an AV canal defect, that's a huge flag for Down syndrome. You see an ASD plus some specific hand defects, that points to something called Holt-Oram syndrome. You see, spotting that one thing on the heart X-ray can be the single key that unlocks a much bigger genetic diagnosis, and that can shape the entire care plan for that child. And really, that's the incredible power of all of this. It's this amazing journey of deduction. Our detective starts with nothing more than a flat, shadowy image, but by following the clues, piece by piece, they can build a complete picture of a child's health. And that, of course, leads to interventions that literally save lives.
It really makes you stop and think, doesn't it? This whole idea of recognizing patterns, it's at the core of so much in medicine and science, really in everything we do. So the question I want to leave you with is this. What other invisible puzzles are out there, all around us, just waiting for someone to learn how to see the pattern?